guys, welcome to my live session. So please join quickly so that I can see how many of you are there right now in the competitive mode, and then we can proceed with the MCQs of the solution chapter. So I'm expecting you people, please share the link with your friends as well. Each and everyone, please share with at least 3 to 4 of your friends so that they can also get the benefits of it, and you can also get to know where actually the competition is lying right now. Hello Rukmini, hello Nagaraja, good evening to all of you. Good evening. Join quickly. Whoever has joined till now, kindly tell me in the comment section that how much you have prepared this chapter. Are you comfortable enough with this chapter? Like rate this chapter among 1 to 5. If you are very good, you have proper grip in this chapter, please rate it as 5. I can see 7 people are there. I'm expecting more of you can join over here, and then we can proceed with the solution chapter. Until then, I just need some little bit of update about your preparation about this chapter. So here today what actually we are going to do, definitely we will solve some MCQ from the question bank. And okay, Siddhar, you love chemistry. It's really nice to know that someone loves chemistry, because people used to hate chemistry as much I have seen in this particular age. Even for me as well, it was quite same. Krishna, hello Krishna. Okay, Raghu, don't worry. If you are having tomorrow second unit test, then if you are having the chapter solution, then it's going to be really helpful for you, because we are really going to deal with some very important MCQ today. Kindly tell me how much you are prepared about this chapter, so that you people also can get the information that where actually you are standing and where your competitors are standing right now. And then slowly we will get into the MCQs. And it's not only the MCQ solution, right? It's not I'm just going to tell you the answers. Rather, I'm assuring you, once I will finish this, you will get an overview of the chapter, that yes, these topics are included, this particular thing I have to be prepared of. From this particular zone I am going to get the question. I will discuss some tricks, some tips, so that if some particular topic or particular zone it's unknown to you, you have never studied, or you missed that particular portion from your NCERT or somewhere else, whatever the book you prefer, then how you should proceed with the MCQ. So yeah, it's going to be little exciting. Okay, Krishna, chemistry is very easy if we understand the concept. Absolutely correct. If you understand the concept, the chemistry is the easiest one. Nice to hear this type of comments from you people. Okay, so let me get into the chapter, so that we can do some more, we can target for some more MCQ. By that time, please keep sharing, keep liking this. Okay, let's proceed. So here we will solve the MCQ actually topic wise. There are different topic comes as you know. The first thing we will proceed with the types of solution, and here we will solve some type of MCQs in ideal, non-ideal solutions, solubility, concentration terms, different topics are there, no? On the basis of the topics we are going to solve the MCQs here. Okay, so let's see. First question is, match the following type solution with their examples. So it's gonna be a very easy question, and you should like mark it like with a full confidence, right? It's a sure shot question. So first one, you can see the type of solution is a gaseous one, right? So whenever it is a gaseous one, and look at the options over here: dissolved oxygen in drinking water, amalgam of mercury with sodium, atmospheric air, and another one is silicon. So gaseous solution means the physical appearance, the physical state of the solution must be gaseous, right? It should be in gaseous state, right? So definitely your answer for the first one is going to be R. Okay, now let's proceed for the option B, that is a liquid solution. So liquid solution is which one? Dissolved oxygen in the drinking water. So this is my P. Solid solution. Solid solution means after making the solution, you will see that the appearance should be in the solid state, right? So you can mark it as an amalgam, right? And there is no use of silicon. So let's check it. It's going to be option B. Okay, anyone? Sanjana, Rukmini, very good, and thanks to you for giving the correct answer before me. Thank you. Let's proceed further. I want all of you to try this out actually. It should not be a one-way interaction. I want you people to interact with me so that I can understand how much powerful our students are. Please do it. Try to give the answer before me. Next question is, which of the following is dependent on temperature? So if you know the answer, please type. Okay, Rukmini already gave the answer, that is the molarity. Okay, anyone else? If anyone knows the answer, please give it. Okay, so Rukmini, you are absolutely true, and another one is Sanjana. Very good, both of you. It's molarity, but here I am going to tell you the reason why molarity, why not the other option, why the other options are wrong. So molarity, if you just imagine what is a proper definition of molarity. Molarity is the number of moles present in 1 liter of solution, right? 1 liter of the solution means number of moles divided by the volume. Right? Now imagine volume is a temperature dependent factor, right? So as volume is a temperature dependent factor, hence entire molarity is also a temperature dependent factor. Now let me just tell about the mole fraction. Mole fraction is unitless because what we put let's say N of solute divided by total number of moles. Number of moles of solute divided by total number of moles. So both of them are mole, they gets cancelled out. So there is no variance with the temperature. So it's cancelled. Now see weight percentage. So weight percentage, here also both numerator and denominator we use the same unit, that is a gram. They gets cancelled out and there is no variance with the temperature. Fine. Now molality. Molality, what we do? Number of moles divided by kg or weight of the solvent. So weight is not variable with temperature, and thus molality is not dependent upon temperature, only the molarity. Okay, yes, very good. Let's proceed. Okay, the next question, the mass percentage, that is W by W of glucose in water is 10%. Okay, that means, and you have ABCD option. If you know the answer, please give me. Yes, please. Anyone else? If you know the answer, please give me. First option, you can see 10 gram of glucose dissolved in 100 gram of water. Next option is 10 gram of glucose dissolved in 10 gram of water. Next one is 10 gram of glucose dissolved in 90 gram of water. Next one, 10 gram of glucose dissolved in 90 ml of water. If you know the answer, kindly type it in the comment box. what do you mean by weight percentage? What do you mean by weight percentage? So if you do this thing, W by W, it means weight of the solute divided by weight of the solvent into 100, right? So with this particular regard, if you just see the option B1, 10 gram of glucose, look at the option C, 10 gram of glucose dissolved in 90 gram of water, because I need in the denominator part the weight of the solvent, right? If my overall solution is 100, definitely it's a percentage, right? They told 10%. 10% means 10 in 100. 100 is the weight of the solution. So what is the weight of solvent? It is a 90 gram is the weight of the solvent. Okay, 90 gram is the weight of the solvent. So simply just 10%, if you just look at 10%, it indicates 10 gram of solute present in 100 gram of solvent. 100 gram of solvent. So here actually you can directly write the solution, because by definition it comes solution. Now as they are asking with respect to water, not with respect to solution, then you can tell that it's a 90 gram of water. Okay, so let's proceed for the next one. You can see the next question. The mole fraction of the solute in 1 molar aqueous solution. 1 molar aqueous solution. If you know the answer, please give it a try. I'm expecting answers from you. If you know the answer, please give it a try. Here you can see, if you are having like 1 molar aqueous solution, it means by default they gave the information I am having 1 mole of solute present in 1000 gram of water, right? 1000 gram of water. So 1 mole, so number of moles of solute, if I ask, it is already given, it is 1. Now number of moles of solvent, if I am asking, that I don't have, I have to calculate it. From where I should calculate? Number of moles equals to given weight divided by molecular weight, right? This thing we know. So number of solvent we are going to calculate. So here given weight is how much? 1000 gram, because by default 1 molar indicates this thing, right? By definition we get the information, right? So from here I can get it like given weight is how much? Given weight is 1000 gram divided by molecular weight is 18 gram. Okay, so now from here if you proceed, you will get almost equals to 55.56 mole, right? Now simply you put into the formula of mole fraction. So mole fraction, if you want to calculate mole fraction of the solute, what is the formula? Number of moles of solute divided by number of moles of solute plus number of moles of solvent. Put the value over there. This is 1 divided by 1 plus 55.5. Okay, so if you calculate this, your answer will be almost equals to 0.018. Okay, so you can tell that option B is the correct one. So this type of tricky numerical you can expect. For these particular case, at first see what informations are given in the questions. Okay, so here you can see by default, by looking at 1 molal solution, right, 1 molal solution, I can understand that it's 1 mole present in 1000 gram, 1 mole present in 1000 gram. By default I can understand this. So write down the information one by one and then you check what actually you need, right, and analysis to get that what actually you have to find out. Okay, then you can connect it. Okay, see here what I saw, actually in order to calculate the mole fraction of solute I need the number of moles of solvent. From here I got the amount of solvent, right. From here I just calculated the number of moles of solvent and I simply put it into the formula. Okay, I guess you understood this. Let's proceed further. Now you can see, here comes the next question. If 1 mole of a substance is present in 1 kg of solvent, then what is the first option is it shows molar concentration, it shows molal concentration, it shows normality, it shows strength, that is gram by gram, right. So now my request to you, please give it a try if you know the answer. Okay, so if you have guessed it, very good. If you have not understood, let me tell you, if 1 mole of substance is present in 1 kg of solvent, so it is a definition of what? You have studied the concentration term, right? It is a definition of molality. It is the definition of molality. Number of moles present, number of moles present in 1 kg solvent, number of mole present in 1 kg solvent, that indicates molality. So they said that it is an 1 molal solution, right? You can see 1 mole present over there, so you can directly mark it shows molal concentration. Okay, so I guess you understood. Let's proceed for the next one. Okay, so go through the question. If you have understood, then please give me the answer. A binary solution has 2 components A and B. The mole fraction of component A is 0.5. Then the number of moles of the component A and B in the solution is, and you have 4 options out of it. How you should proceed? Check if you can do it. Give it a try, all of you. Okay, so if you have understood this, then very good. Or else, let me just proceed with the answer. Some of you constantly giving answers. Okay, I can see it's Rukmini. Very good. You already gave the answer. Last case, Krishna already gave the answer. Okay, let's proceed. Here you can see I am having the information for component A. The mole fraction is given, means XA is given as 0.5, right? Then the number of moles I have to calculate. So what is XA? I can write N of A divided by NA plus NB, that is equals to 0.5, right? So from here I can get NA equals to 0.5 into NA plus 0.5 into NB. Okay, so from here what I'm getting, NA minus 0.5 of NA equals to 0.5 of NB. Okay, so from there I can get 0.5 of NA equals to 0.5 of NB, and both sides 0.5 will be cancelled out, and hence NA equals to NB. So option C is going to be the correct one. Okay, very good, Rukmini, you are too confident for your answer. C. Okay, very nice to see that. Okay, let's proceed for the next one. Okay, so here you can see the next question comes, that is the concentration of fluoride ions to be present in water to prevent tooth decay. It's something that you need to know. Actually, it's not something that will come out of any calculation or something. It's a fact-based question. You should know it, and then only you can answer. Okay, if you know the answer, please tell me. Yes. Hurry up, students, hurry up. Okay, again Rukmini came. Very good, Rukmini. I'm very much happy with your performance. It's option A. So just with a small information that I wanna give you. So this 1 ppm of fluoride that should be present in your water, it converts hydroxyperite into a more decay resistant substance that is called fluoropelite. Okay, that is called fluoropelite. Okay, so as a result of this, your decay will be prevented. Okay, let's proceed. Okay, next question you can see, it's a match the following concentration term solution with their units. Students, expecting answer from you. First one is molarity, then it is molality, then mole fraction, then molar mass, then ebullioscopic constant or cryoscopic constant. Okay, so let's do one by one. So molarity is number of moles of solute present in a certain volume. Okay, a volume of solvent, you can tell, volume of solution, right? So volume of solution should be there in the denominator. So mole by volume. So here you can see where there are the volume unit in the denominator, it is decimeter cube. So with A I am taking S. Okay, now molality, it's mole divided by weight of the solvent. So weight unit is kg. So this is gonna be here. Okay, next is mole fraction. Mole fraction, what happens? Mole gets cancelled out in the numerator and the denominator, and hence it has no unit. Next comes molar mass. Molar mass that we usually write in gram. So gram per mole, it should be P, and ebullioscopic constant, finally it's going to be Q, right? So your answer is going to be A equals to A is going to be S, B is going to be R, C is going to be T, D is going to be P, E is going to be Q. Option A. Okay, again Rukmini, option A, very good. Krishna, just see properly. Don't be very fast to give the answer. Okay, think about it, relate the thing, and then answer. Okay, let's proceed further. Okay, so next question, the tank used by most of the scuba divers is filled with air diluted with helium of around what percentage? Tell me the answer. Yes, if you know the answer, please tell me. So let me tell you this. Here the percentage of helium is 11.7. So I guess you have studied, it's from the application of the Henry's law, that helium is used in the scuba divers tanker so that it can prevent bend. Okay, so just little bit relaxation. Why relaxation? Just I'm going to tell what actually happens here. So during the bend, so when a scuba diver is going into the deep of the ocean, then the pressure of the water increases. Okay, so as the pressure of the water increases over there, then the solubility of the gas increases. That is the Henry's law, right? With the increase of pressure, solubility will increase. So here in this scenario, what happens? In the particular tank, I'm having oxygen, I'm having nitrogen as well. Okay, nitrogen gets more soluble in the blood in high pressure. Okay, so nitrogen starts to get soluble in the blood. Okay, so later when they come out of the deep ocean, when they come out, then the pressure is slowly decreasing, and that particular nitrogen gas bubbles out from that blood. Okay, that nitrogen gas, that they bubbles out from the blood, because initially it got soluble in the blood flow, right? And that becomes very much painful, right? So this is called bend. To prevent it, we use 11.7% helium. Okay, in presence of helium, nitrogen don't get dissolved into the blood. Okay, let's proceed. Very good, Rukmini. Let's proceed for the next one. Here comes your next question. Okay, so a student took 2 glasses of pure water from a water filter. Very good. He cools glass A in a fridge and warms the other glass B on a stove. On comparing the solubility of oxygen in H2O in glass A and glass B, he states that glass A contains, you have option, more oxygen than glass B, less oxygen than glass B. Just go through it and try to give the answer. Yes, try to give the answer. Okay, again Rukmini, fastest finger, she is saying that it's option A. Okay, so yes Rukmini, you're absolutely correct. The correct answer is option A. Now let me just tell you why it is like that. So solubility of gas, remember this key factor, solubility of gas is inversely proportional to temperature. It's inversely proportional to temperature. So container A, what you did, you freezed it, right? You decreased the temperature, right? And hence solubility of the gas will increase, and hence you will find more dissolved oxygen in that particular case, right? Okay, very good. Let's proceed further. Okay, so this question, this is from the vapor pressure of the liquid solution. Okay, so let's proceed. PA and PB are the vapor pressure of the pure liquid components A and B, okay, respectively of an ideal binary solution. Fine. Next, if XA represents the mole fraction of the component A, then the total pressure, what will be the total pressure? Okay, so for this particular case, you definitely have to add, you definitely have to apply Raoult's law. Okay, so please give it a try, students. Okay, I'm getting a new student. Okay, it's not new actually, earlier also I got answer, Gagana. Okay, you are telling that it is option A. Let's see. So here how you should proceed actually, you should start deriving the Raoult's law, you will get it. Okay, so let's say I am having pressure of A. Pressure of A equals to mole fraction of A into vapor pressure of A whenever it is in the pure state, right? And P of B if you write, then it is basically x of B into PB naught, that is the vapor pressure at its pure state. Okay, so for to make it easy, you know, I'm just referring this PA0 and PB0 at normal PA and PB respectively. Okay, so now if I just proceed with the total pressure of the solution, it must be this plus this, so XA into PA plus XB into PB. So you know, I guess this is the Raoult's law, right? Okay, so now let's proceed further. So here what I'm going to do is XB, we know XA plus XB, the mole fraction of the two component of a binary solution is always 1, right? So from here XB can be written as 1 minus XA, right? So let's replace this thing into this equation. Okay, so from here I'm getting PT equals to XA into PA plus 1 minus XA into PB. Okay, now from here if I take common XA, so I am getting PB plus XA into PA minus PB. So this is what I am getting. So let's check. It's option D. Who said? Okay, so organic chemistry is too tough. No beta, organic chemistry is not really too tough. I have some tricks that I can share with you. So that's the reason you have to keep watching and you have to see on the videos that are going to come in the next few days. So there I will tell you some trick and you will find, okay, organic chemistry is the easiest one. Okay, it's my assurance to you people. Okay, so let's proceed further. Let's proceed. Okay, this question please go through. The vapor pressure of two liquids P and Q are 80 and 60 torr respectively. The total vapor pressure of solution obtained by mixing 3 mole of P and 2 mole of Q would be, the options are there. So directly you apply Raoult's law. Okay. Okay, please bring your sessions, ma'am. I need for kcet. Definitely, don't worry, beta. It will come very soon, and definitely we are going to help you out in the every possible direction. See, organic chemistry is something that if you keep by hearting, no, it will be so disgusting, so boring that you will feel like no, it's chemistry is not my cup of tea. But once you will go to the depth, means sometimes what my trick, let me just share these things with you a little. I was very much interested in learning the background story of the reaction sometime. Okay, like few name reaction, like the name of the scientist, you know, the Cannizzaro reaction. Okay, so there are beautiful, wonderful stories. So what we actually do, if I tell you a formula, if I write it, you will not remember. If I do a reaction mechanism, you will not remember. But if you go to like a cinema hall and if you just watch a movie of Shah Rukh Khan or of your favorite hero, you will remember the entire story of 3 hours. Am I right? So take the organic chemistry in that way. Otherwise, you are going to forget. Okay, so I will definitely help you in the upcoming sessions so that I can make organic chemistry as a complete film. Okay, so Okay, ma'am, hearing you feels like I need to watch your upcoming lectures in organic. Hope God provides your lecture very soon in organic. Okay, definitely. We will again meet with you in our upcoming session. Okay, so okay, Rukmini, aldehyde ketone carboxylic acid MCQ also will come. Don't worry, one by one we will proceed. Okay, so we will make a film on organic chemistry, not a session. Okay, let's proceed. Okay guys, please tell me the answer of this question. Fast. If you could do it, simply just apply Raoult's law and you will get the answer. So here, okay, someone, it's Ratul. It's 140, he said. So anyone else? Someone said Mansi, it's 20. Rukmini also, it's 20. Okay, let me calculate once. Okay, I will directly apply over here. I am not calculating the mole fraction individually. We will do directly here. Okay, so total pressure, if you proceed, so it should be mole fraction of, what are the component? P. Mole fraction of P into pressure of P, right? Plus mole fraction of Q into pressure of Q. Right? Now if you just proceed with the thing, now what is a mole fraction formula? It is the number of solute divided by total number of moles. So what is the number of solute for P? It's 3, right? 3 divided by 3 plus 2, it's 5, into it's 80 plus here I am going to get 2 divided by 5 into how much they give? It's 60. Okay, Sumit Kumar, ma'am, first PUC chemistry classes. Okay, definitely we will proceed with the first PUC as well in the upcoming future. Okay, so let's proceed. You can see, if you just simply calculate this particular thing, so you will get out of it 72 torr. Okay, so the correct answer is going to be option A. How we will say that? Okay, someone told something and then deleted. It's fine, not an issue. So basically, how we will predict? It's simply, these are the numerical based question, my dear. Okay, simply if you just if you just proceed with the formulas, then you can just put the values over there, check what informations actually are given here. Okay, and then relate which formula you can apply. Okay, sometimes you will tell me, then ma'am, we can't relate. Okay, so that's the reason you need to go through the formulas. Okay, so for the formulas you need to know the concepts, and for the concept build up, that film, okay, that film needs to be there in front of your eyes. Okay, by doing this I will get that. Okay, once you have the proper idea how you are getting the formula, then you are not going to forget the formula, it's my assurance. Okay, so that's the reason I sometimes insist my student to proceed with the derivation. Okay, please learn derivation so that you understand. It's not by like you are by hurting the thing, you are understanding how the things are coming. Okay, let's proceed for the next one. Okay, an aqueous solution is 1 mole in Ki. Okay, which change will cause the vapor pressure of the solution to increase? Okay, please tell me the answer, students. You are doing really well. I am really impressed. Please give me more answers. So first one is addition of NaCl, next one is addition of Na2SO4, next one is addition of again 1 mole Ki, next is addition of water. Think, okay, I got the answer from Rukmini, very good my dear, it's option D. Okay, so just imagine how you should get the answer basically. So here what happens, if you add solvent, means just imagine like how the vapor pressure should come. How? Who will give you the vapor pressure, Ki or water? Water there in the solution, it's Ki, that is solid, right? Non-volatile solid, better to say non-volatile solid, that will not contribute in the vapor pressure. Another one is water, right? So if you increase definitely the amount of water, that water will give rise the vapor pressure, right? If you add NaCl, it will decrease the vapor pressure, right? More amount of non-volatile solute you are adding, RLVP, relative lowering of vapor pressure, right? Colligative property. Okay, Na2SO4, same. Again you are adding Ki, same thing. Addition of water will increase the vapor pressure, right? Okay, so let's proceed further. The correct option is going to be D. Let's proceed. Okay, the mixture which shows positive deviation from Raoult's law. Positive deviation from Raoult's law. Okay, we are coming in the new topic. We are entering ideal and non-ideal solutions. Okay, so first question is the mixture which shows positive deviation. Here I am having N-hexane, N-heptane. Option B is bromoethane and chloroethane. Next one is ethanol and acetone. The last one is chloroform and acetone. Give the answer, give the answer. Okay. I got the answer from Rukmini. It's option C. Okay, ethanol and acetone. Okay, so definitely it's gonna be the correct answer. Now let me explain why the other options are wrong and why this one is correct. Okay, let's proceed. N-hexane and N-heptane, they are homolog to each other, right? They are in the they are member of the homologous series. So we know when we are having the members of the homologous series, we are having the ideal solution, and ideal solution never ever deviate from Raoult's law. Okay, so in the first case there is no question of deviation. Okay, next bromoethane and chloroethane, same thing again. Okay, ideal solution. Next, ethanol and acetone. So what happens basically here in the ethanol, you are having some ethanol hydrogen bondings are there, and if you just look at acetone acetone bondings are also there, right? Acetone bonding, what type of bonding? You can see it's a polar molecule, right? So dipole interaction you can see, London dispersion force you can see, so AA and BB interaction you can see. Nicely it's observed. Okay, now whenever you are mixing ethanol and acetone, then in between two ethanol, acetone will be accommodated, right? So interaction will be less, right? Where two ethanol side by side, they were making nice hydrogen bonding. Now in the middle, acetone will come and the bonding will be disrupted, right? So ethanol acetone interaction is greater than that of ethanol acetone interaction, means AA BB interaction is greater than that of AB interaction. So this is the criteria of the positive deviation of Raoult's law. Right? Now if you just look at the chloroform and acetone, whenever chloroform and acetone are mixed, chloroform and acetone are gets attached with the more stronger hydrogen bonding, and hence AB interaction becomes greater than that of AA and BB, and hence it shows negative deviation. Okay, so I guess you understood why C is correct and the rest of options are wrong. Okay, let's proceed further. Okay, your next question is a mixture that forms maximum boiling azeotrope. What is azeotrope? Who can tell me? Anyone is there who can tell me what is azeotrope? Anyone who can tell me the azeotrope? So let me tell you, azeotropes are those solution whenever in the liquid phase and in the vapor phase composition are same. Okay, so what I said, azeotropes are those, that particular condition whenever the composition in the liquid phase and in the vapor phase is same. So there comes two different type of azeotrope, you know, maximum boiling azeotrope and minimum boiling azeotrope. Okay, so just let me write a little bit so that you can get a little bit hint. Okay, I got some answer from Krishna. Very good, Krishna. Krishna is saying option B is the correct one. Let's see. So maximum boiling azeotrope is observed by those solution who actually shows large negative deviation of Raoult's law. Okay, so negative deviation indicates when AB interaction is more than that of the AA interaction and BB interaction. Right? If you understood this particular scheme, you can answer this question. So heptane and octane, they are having quite similar type of interaction among themselves, hence it is a ideal solution, no deviation at all. Water and nitric acid, okay, water and nitric acid, AB interaction is more than that of the AA and BB, hydrogen bonding are there, right? So you can mark it as a correct one. Okay, let's proceed for the next one. Okay, so go through the question. All form ideal solution except that you have to find out. So in the last question itself we discussed this particular concept. So I want you people to give it a try. Tell me the answer. Quickly tell me the answer. So if you just look at the first one, they will show kind of similar type of interaction among themselves. Okay, I got the answer from again Krishna Talwar. Very good, my dear. It's option D. Yes, option D is the correct one. Let me just explain why the rest of the things are not correct. Okay, so the first three things, if you just look at that, they are of same type of thing, same type of compound. Okay, so C2H6Br, C2H5I, they are of same type of compound, right? Hence they will show they are ideal in nature, there is no deviation at all. But whenever it comes to C2H5I and C2H5OH, then let me tell you, this C2H5I is a polar, right? It's a polar compound, so you can expect dipole-dipole interaction and London dispersion force as well. And if you just look at C2H5OH, here I am having strong hydrogen bond. Okay, so very good. Let's proceed. Next we will proceed with, okay, we are entering into the colligative property. Okay, so in a solution containing non-volatile solute, the mole fraction of a solvent is 0.9. The relative lowering of vapor pressure you have to find out. Okay, how you should do it? Give it a try. Give it a try and tell me the answer. Okay, I am getting the answer from Rukmini. She is saying that option B is the correct one. Okay, so let me tell you, relative lowering of vapor pressure, relative lowering of vapor pressure is nothing but mole fraction of the solute itself. Okay, so they gave the solvent mole fraction. So mole fraction of solvent is given, that is 0.9, and hence mole fraction of solute, it comes 1 minus 0.9 and hence equals to 0.1. So that's going to be the relative lowering of vapor pressure. So option B is the correct one. Okay, very good. Let's proceed further. Okay, so at 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 molar solution. And you have to assume the complete dissociation of the compound. Okay, give it a try, all of you, and tell me the answer. So, how you should deal with this type of question? So here let's find out the Van't factor. Okay, so why Van't factor? Because my like relative lowering osmotic pressure they are asking, right? So pi equals to CRT in general, but whenever we are considering the Van't factor, that comes with I into CRT, right? Or C is the 0.1 molar, it's given already, CRT. Now you check where the I is maximum among this. So glucose being a non-electrolyte, it don't dissociate, right? It's a non-electrolyte. So I is going to be 1. Only one particle available for the glucose, no dissociation out of it. Now if you just look at the urea as well, urea also, it cannot dissociate, and hence here also I is 1. Look at KCl. KCl dissociates into K plus Cl minus. How many ions you are getting? You are getting 2 ions out of it, right? So your I value is 2 here. Now look at, for this case, it breaks down like Ca2 plus 2 Cl minus, and hence how many ions you are getting? You are getting 3 ions. So I value should be 3. So I is maximum for this case, so 3 CRT. So this is going to be the correct option. Okay, again Rukmini, very good. Let's proceed further. Okay, so the next question, let's proceed. Okay, the Van't factor you are asking, Krishna. So how you should actually find out the Van't factor? Van't factor actually it comes from the abnormal molecular mass. Okay, so why this abnormality come? Let's say you are dissolving KCl in water. Suppose you are dissolving KCl in water. Okay, so whenever it's in your hand, you haven't dissolved yet. KCl is a single particle, right? One KCl only. But whenever, as soon as you are dissolving it, KCl is breaking down, right? How many particles you are getting? From 1 particle, you are getting 2 particles, right? So, because of the 2 particles, both of them are non-volatile. Your relative lowering of vapor pressure or whatever the colligative property, you will observe there will be less vapor pressure. Initially it was 1, after dissolving it becomes 2, right? So this particular factor indicates how many particles actually you are having in your effective solution, right? So how you should get it? Simply just dissociate them, and you will count the ions, the number of ions it will form, and you will get the answer. like glucose. If you just look at the glucose, if your hand you are having glucose and if you dissolve it in water as well, then also it will be single glucose molecule only, because glucose cannot dissociate, it's non-electrolyte, right? Urea, it's also non-electrolyte. So Van't factor is 1, only one particle. But if you dissolve CaCl2, you will get Ca2 plus 2Cl minus. How many ions? 3 ion. You are starting with CaCl2, a single particle, but after getting dissociated, it's becoming 3. So it's affecting the colligative property, right? In the maximum possible way, right? So the highest osmotic pressure you will see here. Osmotic pressure is one of the colligative property only, right? So highest you will see for this case. So please tell me if you understood or not. Krishna, I'm expecting that you tell me if you understood these things or not. By that time, let's proceed with the next one. Okay, so you can see next question is something. Of the following 0.10 molar aqueous solutions, which one will exhibit the largest freezing point depression? Largest freezing point depression. Okay, so let's proceed with this question. So here again what I have to do, see delta TF is the depression in freezing point. So what is the formula? Delta TF equals to Kf into m, right? This is the formula. This is the formula. So whenever you are just taking account the Van't factor, just like multiply I, right? So now what you have to do, you already understood, find out the I value. So for KCl, so what is the, because molality is same for all the cases, right? For KCl how much it is coming? It's 2, right? I equals to 2, K plus Cl minus, Al2SO4 whole thrice. So it is coming 2Al3 plus plus SO4 2 minus, how many ion? 2 plus 1, 3 ions are coming over there. Okay, wait, 3 SO4 2 minus, so overall 5 is coming, right? So I value is coming 5, right? I value is coming 5. For this case, you cannot dissociate this thing. So for this case, I equals to 1. For this case, 2K plus SO4 2 minus, okay? So 2 and here 1. So overall I is coming 3. So maximum value I can see for this case. So here only you will observe maximum depression in freezing point. Okay, again Rukmini, Krishna, very good. Let's proceed for the next one. Okay, which of the following aqueous solution has minimum freezing point? Okay, minimum freezing point. Okay, let's proceed. Here you can see the molality also is changed, so you have to find out. So one by one, let's see. I am first having 0.01 molar NaCl. So I value is for NaCl, Na plus and Cl minus, so I value is coming as 2, right? So hence delta TF I am having, see each and every case is what you are having, I into Kf into m. This formula is same, just value of I will be changing and the m will be changing. Okay, so 2 into Kf into 0.01 to 0.02 Kf. Fine. For option B, I am having 0.005 molar C2H5OH, right? So for C2H5OH it will not dissociate and hence I will be 1. So delta TF value if you calculate, it will be simply 1 into Kf into 0.005 and hence 0.005 Kf, right? If I do for C, 0.005 molar Mgi2. So how it will dissociate? Mg2 plus 2I minus, right? So from here I value will come 3. I value will come 3. So from here what I am doing, delta TF will come, I guess you understood this, 0.015 kf, right? The last one, option D, that is 0.005 molal MgSO4, right? So here I value is coming how much? Here I value is coming as 2, and hence delta TF will come as 0.01, right? So now if you just see, I am getting the least value, or sorry, maximum value here, okay? I am having the maximum value here, right? 0.02 over here, okay? And hence you can tell that this is going to be the correct answer, that is option A. Okay, so whenever see, it's a factor like whenever you are having the colligative properties, then you can use Vanta factor simply, okay? So whenever they are giving some electrolyte, okay, or molality is directly given, right? See, analyze with the data that is given to you, fine? So if you analyze with the data, like here I am having different type of salt, right? Different type of salt, different type of compound, right? So for them I will be using different Vanta factor because they dissociate in a different way, okay? Now you may have the question, then when I will use only Kf into M? That particular case, your all the solution should be of a single compound. There should not be different compound. They should be a single compound, simple compound, right? And all the data that is possible, number of moles, whatever you need to find out the molality, that will be provided, and you will understand, okay, Kf into M I have to do, we will proceed accordingly, right? But whenever you are comparing this thing, comparing with a different solution, then you can use a Vanta factor, okay? I guess I could clarify your doubt. More you will practice, more different type of problem you will practice, you will get to know where and when you should actually use this type of thing, okay? Let's proceed further. Okay, so here comes the next question, that is for 0.1 molar solution, the colligative property will follow the order. So here again what you have to do, again you simply calculate the Vanta factor, okay? So what type of solution you are having? You are having NaCl, you are having Na2SO4, you are having Na3PO4, okay? So for NaCl, it will dissociate in Na plus Cl minus, hence Vanta factor is going to be 2. For this you are having 2 Na plus SO4 2 minus, and hence your I value should be 3. For this case it should be 3 Na plus PO4 3 minus, hence your I is here 3 plus 1 4, okay? So definitely you got the answer, it's going to be B, okay? Very good, let's proceed further. Okay, on assuming complete dissociation, the aqueous solution having highest fizzing point, okay, here you can give it a try. So both of the cases the molarity is same, and again the Vanta factor is also given. See, they are asking the highest freezing point. Highest freezing point means maximum or minimum, sorry, highest freezing point means minimum deviation, right? Minimum del TF. Minimum del TF, minimum depression in freezing point, right? So where it is possible, minimum value when we should get, when the I value is less. So I value is less for the first case, so hence your answer is going to be this one, Okay, highest freezing point they are asking. Okay, highest freezing point. Okay, delta TF means what? Delta TF means depression in freezing point. Freezing point will be depressed, but I need highest, means I need the value towards the positive, right? So delta TF value is going to be negative if I value is more. Okay, but they are asking for the highest one, right? So you have to check for the minimum delta TF. Okay, and hence here I am having I value less, and hence this is the correct answer. Okay, let's proceed next. Here you can see when compared to delta TF value of 0.1 molar glucose solution, that delta TF value of 0.01 molar magnesium chloride solution, you can see if it is increases 3 times or if it is about 6 times, again you have to calculate the same thing. Okay, so molarity is quite similar. So magnesium chloride, if it breaks down, you will get magnesium and 2 chlorine, right? Out of it Mg2 plus plus 2Cl minus, and hence overall value is coming 3, right? So it will be increasing 3 times. Okay, let's proceed. Okay, tell me the answer. I guess you know this thing. Tell me the answer. I'm expecting this thing. Which of the following compounds can be used as an antifreeze in automobile radiator? Tell me the answer. Yes, student, please tell me. So here it's a fact-based question. Let me tell you, it's basically ethyl alcohol or ethylene glycol that we actually use as a automobile radiator. Okay, let's proceed. Okay, glycol is option. Glycol option is there, so you can mark it. Glycol means 2 OH group should be there. Okay, so glycol, ethylene glycol actually. Let's proceed further. Okay, so now you can see the question. If the molality of the dilute solution is doubled, the value of the molar depression constant, that is Kf. Tell me the answer. Yes, give it a try. So basically let me tell you, Kf here it will not change with anything, means for any solvent the Kf value is already fixed. Even if you dilute it, if you make it more concentrated, the Kf value, it only something depends upon the molar mass of the solvent or the enthalpy of fusion. Okay, if you just see the like a form of Kf, then you can understand this thing. So it will be unchanged. Okay, let's proceed for the next one. Okay, so yeah, it's a nice question actually. The relationship between the osmotic pressure when 10 gram of glucose, 10 gram of urea and 10 gram of sucrose are dissolved in 250 ml of water. Okay, give it a try all of you. Again you have to apply the same formula, that is pi equals to I into M into R T. Fine. Now here you can see this M or the molar concentration. M is the molar concentration here. Okay, how you should find out? So you can see pi is directly proportional to M. From here I am getting. So what is molar concentration? Molar concentration is nothing but you can do simply N by V. N by V. Okay, so N further if you want to write, given mass divided by molecular weight into V, right? So from here you can see pi is directly proportional to M, that is the molar concentration, and hence inversely proportional to molecular weight, right? Inversely proportional to molecular weight, correct? Now you can see all of them are having 10 gram, 10 gram, 10 gram. So what we have to analyze? The molecular weight. So molecular weight of glucose is 180, for urea it is 60, and for sucrose I guess it's 342. Okay, so with that perspective, definitely it's going to be P2 greater than P1, then P3. This is going to be the correct one. Okay, so very good, Rukmini. Let's proceed. Okay, so this question is a very common question to you people. I guess you can understand this as well. So here you can see the blood cell retain their normal shape in solution, which are first of all hypotonic, isotonic. You can just tell me the answer simply. So if isotonic means what? Isotonic means whenever they are of similar concentration. They are of similar concentration. So if they are of similar concentration, there will be no exchange of solvent, right? If there is no exchange of solvent, then it will be as it is. So this is going to be the answer. Okay, very good, Rukmini. Let's proceed further. Okay, so this particular chapter, I mean this particular topic is going to be the last topic. Okay, so we will proceed with this question, and then I guess we covered the entire MCQ of this particular chapter. From every particular zone we just took out some MCQs and some important concepts we already discussed. Let's proceed with the last question of today. Which of the following salts has the same value of Vanta factor I as that of K3 FeCN6? So this is a coordination compound, right? So whatever is there in the coordination entity, they will not break, right? So if you simply just ionize it, you will get 3K plus FeCN6 3 minus, right? So how many ions you are getting? It's 4, right? So I equals to 4. So with that particular case, you have to find out in which case you will be having the I value 4. So if you just look for this one, aluminium sulfate, I guess it will be having 5, I equals to 5. Okay, NaCl, I equals to 2, Na2SO4. So for Na2SO4, if you just simply do 2 Na plus it's I equals to 3, it's coming, fine. Okay, for this case, let's proceed. Al3 plus 3 NO3 minus, right? So here you are getting I value as 4. So yeah guys, that's it for today. And okay, someone is asking, okay, Vittal, ma'am, what about the crash course? Yes, we will very soon we will come up with the crash course, and don't worry, there will be some one-shot video and PYQ as well. In those things, your entire concept is going to be clear. Means simply if you just look at the video and if you directly go to the chapter without studying anything, I can assure that you can attempt the questions. Okay, so yeah, we will soon launch that thing as well. So yeah, thank you for being the part of the session, and wish you all the very best for your upcoming test, and keep preparing for yourself, and yeah, do some MCQ practice, focus on them, because this is a thing that is very much unpredictable, right? Rest of the question you can attempt. Some like predictions are there that this question can come, this question can come in 3 marker, 2 marker, like that, but whenever it comes to the MCQs, it's really unpredictable. So that's the reason you need to be a very good analyzer, and please do smart work rather than that of the hard work. So that's it for today. Thank you, my beautiful student. Thank you so much. Bye.